Or maybe purple? Okay. Okay, so today, class, quiet down. Today we're going over circumference and arc lengths. You've already learned how to find the circumference of a circle. Okay, now we're going to learn how to find part of a circle, just the arc length of the circle. So we're going to calculate the circumference of a circle and solve problems involving arc length, and students will define radian measure. Okay, circumference is the distance around the circle. The circumference of a circle, C, of a circle is circumference equals, so you need to highlight this. This is your formulas. Okay. You should already know the circumference. Circumference is pi times diameter. We already talked about what pi is the ratio between the distance around the circle in relation to the diameter. Okay, or you can have the circumference equals 2 pi r, because the radius is just the diameter is equal to 2 radiuses, or radii. Any questions over that? So find the circumference of a circle with a diameter of 6 centimeters. So we're going to draw in a circle with a diameter of 6 centimeters. Our formula, since we are given a diameter, should be diameter times the pi, times pi. So our circumference is going to equal 6 pi. We are not going to leave pi in our answer, so we all need to look at our calculators and find the pi button on our calculator. Okay, we don't plug in 3.14, we find pi button. So everyone looks on your calculator and finds pi. Not yet. Okay, so I plug it into my calculator. And I get my circumference to equal 18.84. Does the 4 make the 8 stay the same or move up? Stay the same. So the circumference is equal to 18.8 centimeters. So if I was trying to run a string along the outside of the circular shape, I would need 18.8 centimeters of string. Any questions over that? Okay, everyone try the circumference of the next one. Okay, so again, for this, since they gave us the radius, we should be using 2 pi r. So our circumference should be 2 pi times the radius of 7. So our circumference is 14 pi. So the circumference then equals 43.98. Does the 8 make the 9 move up? Yes, but when the 9 moves up, that makes the 3 move up. So your circumference is 44 what? Inches. Those two little marks mean inches. Okay. right? 1 foot is just one of the marks. Okay. The quote is inches. I had a student teach me how to remember this because I could never remember which one was which. Okay. And so the rhyme is the less, the more, the less. So the little more, the less, the more, the less. So you have more of the little marks. Okay. Apostrophes. There's 2 apostrophes here, so it's the less, the more. The more, it has more, so it has less, and inches are less than feet, right? So if it has just one little mark, then it would be 7 feet, because it's less means the measurement is more, and 7 feet is more than an inch, okay? If there's 2, then that's inches. So more of the little marks, a little more is less distance. Inches are smaller than feet. That's how I remember it, because it's hard. Okay, next one. Find the circumference of the circle. Any idea how I can do this? Yeah? Very good. Since this side length is 12, that makes the diameter 12 as well. Because I just basically am moving it over, right? Okay, the distance here is the same as the distance here. So this has to be 12 as well. So your circumference is diameter pi. So your circumference is 12 pi. We plug that into our calculator to see what that comes out to. So my circumference is 37.69. Does the 9 make the 6 move up? Yes. So my circumference is 37.7, and then it doesn't give me a unit of measure, so I just put units. Doesn't tell me if it's feet or miles or anything. So I just write like that. Any questions over that? We're good? Okay, now we're going to work backwards. It says find the radius of a circle if the circumference is 52. So this time they give me my circumference equals 52. They asked me for the radius. So I have to use my formula of circumference equals 2 pi times the radius. So I plug it in. 52 equals 2 pi times the radius is what I'm looking for. How do I get the r by itself? Divide by what? Divide by 2 pi. What'd you guys get? Does that make sense? How can the radius be longer than the circumference? It can't. Okay, so we need to make sure we plug in this into our calculator correctly because it's not dividing well for us. So when you plug this into your calculator, you need to put 52. Sorry, let me erase that because that's not what it's going to look like. It's going to be 52 divided by parentheses 2 pi. So you need to plug it in like this. Because what it does without those parentheses, it's going to go 52 divided by 2 and then times pi. That's what it's actually doing if you don't use the parentheses. Okay, so that's why you get the different answer. So then my radius is going to equal 8.27. Does the 7 make the 2 move up? So my radius is 8.3. And then inches. Any questions over that? Okay, a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. Since all circles are similar, find the length of A prime, B prime. So let's review. We have been finding the measure of arcs. Now we're going to be finding the length of arcs. So when it uses these words, length of arc A prime, B prime, they're asking you for a length or a distance. When I ask you to find the measure of arc A prime, B prime, I'm looking for degrees. And that's what we've found before. However, if you guys ever told me, like, hey, I want to build a circular garden in my garden. Hold on. Shh. Okay, so again, if I wanted to build like a circular garden or some sort of arch, I wouldn't want to know the measurements in degrees. I wouldn't say, oh, I wouldn't go to the hardware store and say, I need fence that is 60 degrees. They'd look at me like I was weird, right? So I need to give it to them in a length. So I need like 2.5 feet of fence so I can build it. Does that make sense? So that's why we need to find the arc length. Just a different way to describe the length of the arc. Arc rather than in degrees. Okay, so because we have similar circles here, because all circles are similar. Remember, similarity means they're proportional, the sides are proportional, and all the angles are congruent. Okay. In circles, you don't have angles. You just have like central angles and inscribed angles, but you don't have an angle. And you don't have side lengths. You just have radiuses, right? Or radii. So the radius is the only thing you're gonna need to find the measure of to find the scale factor. So we first want to find the scale factor. And remember, your scale factor is your image over the pre-image. Remember when we have the little prime markings, this is the image. So we have our radius of 6 goes on top, over the radius of 4 on the bottom for the pre-image. They can both be divided by 2 to get 3 over 2. So the scale factor is 3 over 2. So that means that this circle is 1.5 times bigger than our starting circle. So that arc length, this arc length, is going to need to be multiplied by 1.5 to give me the length of this. Does that make sense? Because the ratios are all going to be the same. So you're going to set up your proportion using your scale factor. You're going to use 3 over 2 is going to equal the length of AB, arc AB, A prime, B prime, over the arc length of AB. So I have 3 over 2 is going to equal, since I don't know, that's what I'm looking for. I'm looking for the length of A prime, arc A prime, B prime. So that's my X over, and I was given the arc length of AB. So I plug that in, 2.8. Any questions over that? And then you just solve the proportion. So 2.8 times 3. (8.4) equals 2 times x, which is 2x. Then you divide by 2, and we get x equals 4.2 inches. Any questions over that? So that's how you can find the measure of different arcs in similar circles. Now I have to find the measure of arcs in just a circle. Okay, so in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the circle central angle to 360 degrees. So whatever part of the circle we're given, it's proportional to the degrees. Does that make sense? So you don't have to write this down, but I'm just going to kind of go over this. If I draw a circle, and I draw in a diameters, and I cut my circle into 4 congruent parts. And I wanted to find, let's say, the arc length of this. Just that distance. I just wanted to maybe, again, put a fence over that portion of it. If the circumference here, let's say the circumference was 16. Okay. How much of the circle am I actually going to fence in? 1/4 of it. So the length of this would be 1/4 of 16. So it'd just be 4. So that's all we're really doing, is finding what part of the circle am I using. Okay, sometimes it's going to be easy. It's going to be just 1/4 of it. It's going to be 1/2 of it. It'll be 1/3 of it. Other times it'll be more complicated, and I want to cover 5/6 of it. Does that make sense? So when it's kind of more difficult, you're going to have to use this proportion. When it's easy like this, you can just take the circumference and divide it up by however many you have. Otherwise, you're going to want to use this formula. Okay. The ratio of the central angle to all of the circle is equal to the ratio of the arc length, the part of the circle that you're using, to the whole circumference of the circle. Any questions over that? So let's try this. We're going to use that same formula. In this, my central angle is 124, because we're going to find the length of CD. So that central angle is the central angle of arc DC. So 124 over 360. Now that's not a nice easy number to reduce, so I'm just going to leave it. It should be equal to the arc length. That's what I'm looking for. My arc length is the length of CD. So that's my X. Over 2 pi times the radius. over the circumference. So I'm going to rewrite that. 124 over 360 equals x over 14 pi. And then I'm just going to solve. So 14 pi times 124. I'm going to leave the pi right now and multiply it through at the end, so I don't have to write a bunch of decimals. Then I'm going to do 360 times x is 360x. Any questions over that? Then I'm going to divide by 360. Divide by 360. I'm going to plug that into my calculator. Do 1,736 times pi divided by 360. And I get x equals 15.14. Does the 4 make the 1 move up? Yes or no? Nope. So I'm going to leave it as x equals 15.1 centimeters. So this arc length is 15.1 centimeters. Any questions over that? We're all good? Okay. Next one. Okay, find the length of CD. So we're looking for this. Do I have the central angle there? How do I find that central angle? Subtract from what? 180. This is a diameter because it goes through the center of the circle. So 120 in this equal 180 degrees. So if you just take 180, subtract the 120, you'll get this to be 60 degrees. AC, the whole thing is 10. So the radius is 5. Okay, so everyone find the length of arc CD. And what was the radius? No, the 2 pi r, that you need to have a radius. If the diameter was 10, then the radius should be 5. Okay. So this is just 60 over 360 equals x over 10 pi. You're going to multiply the 2 times the 5 and get 10. Then you're going to cross multiply and get 600. Sorry, that's not an x. That should be a pi. $600 pi equals then 360 times x. Then you divide by the 360, divide by the 360, and you should get x equals 5.23. Does the 3 make the 2 move up? No, so it's just x equals 5.2, and our units are centimeters. So the length of that arc from here to here is 5.2 centimeters. Any questions over that? Okay, now we're going to find the circumference. This time, they gave us the arc length, and they want us to find all the way around the circle. We're still going to use our formula of the central angle. over 360 equals the arc length divided by the circumference. Any questions over that? Okay, so Alex, what is the central angle here? $60 degrees. 360 is always the same. The arc length is given to us right here. 3.82 over my circumference is what I'm looking for. They said find the circumference, so that's my x on the bottom. Okay, you solve the proportion. Cross multiply. Get 60x equals. Then 360 times 3.82. And that gives me 1375.2. Then I divide by 60, divide by 60. Okay, so the circumference of my circle is 22.92. Does the 2 make the 9 move up? Nope. So my circumference is 22.9. What do those two little marks mean? Inches. Any questions over that? Okay, next one. We want to find the distance around a track. Okay, the curves at the end of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path. Let's write this down since yours isn't in color. So the red path is actually the inside track. Just so you know. About how far does the runner travel to go once around the track? Round to the nearest tenth of a meter. Okay, so the blue or the outside track we don't care about. We're only looking at the inside track. So if these two circles are both 180 degrees, they're half a circle, right? And what do 2 halves equal? A whole. So I have 2 halves of a circle. They're cut in half and put on opposite sides of my track. Okay. But I can just find the circumference to find the distance from here to here. I want to know the distance from here to here, and I need to know the distance from here to here. They gave me the distance from here to here is 84.39. And the distance from here to here then is also 84.39. Any questions over that? So to find those 2 missing pieces, we just find the circumference of that circle. So your circumference is going to equal 2 pi times the radius. They gave me the radius here. And they even wrote it in to show the radius on the picture. So the circumference of that circle is 2 pi times 36.8. So let's do that math. And I've got that circumference to equal 231.22. Does the 2 make the 2 go up? No. So circumference equals 231.2. So now to find all the way around, we have to just add it all up. We have 231.2 plus 84.39 plus 84.39. And so the distance equals 400.00, and that would be meters, which makes sense. What's one time around the track? 400. Okay, so you guys should have that extra packet. Okay, let me please get it out. You still have 2 more minutes in here, so hang in there with me, because I want to make sure you don't do